And welcome to Module 4, Lesson 11, Tax, Commissions, Fees, and Other Real-World Percent Problems. Yes, one of the longest lesson titles we will see this year. And lots of fun. This one might take a little bit longer, so I will try not to just talk too much when I don't need to. Okay, so let's go ahead and get right into it and talk about a few of these things here. Okay, so some points about today's lesson or this lesson. Okay, gratuity. Gratuity is one of the things we'll be talking about, one of the items, and gratuity is just it's a tip. Okay, a tip that you leave at a restaurant or elsewhere. Okay, it's a percent usually that you add onto a total bill. For example, in restaurants, if you have 8 or more people, usually, this is the rule, they will add an 18% gratuity. I'm not sure where they came up with that number, but 18% they will add on top of your entire bill. So that is so that's going to add if you have a big bill, it's going to add quite a chunk to your total. Okay, and that's not optional. Okay, gratuity is generally optional. You go to a restaurant or wherever, and you decide what percentage you're going to give to a tip you're going to give to your waiter or waitress, and and that can range. Well, it could be anything, but generally 15-20% is usually typical. Okay, so that's gratuity. Now, commission we talked about in the past. Commission is a rate. Again, it's a percent that a salesperson generally will receive. For example, car salespeople, when they sell a car, they sell a vehicle, they will get a certain percent of that vehicle's total sales price. Let's say about 10%. A realtor, somebody who sells real estate, they generally get about 6%, 3 to 6%. Sometimes they share that with a second realtor, but and that's pretty hefty. It can be. I mean, if you're selling a house for $500,000, for example, 3 to 6% of that $500,000 is quite a bit of change. Some people actually work on only commission. I mean, that's the only money that they make is that percentage. Some people get a salary, a base salary, plus a little bit of commission as well. Taxes, of course, are taxes, and those are things. For example, we pay sales tax. Maybe it's like 7 to 8% in California, and again, that's tacked on to your total bill. Not every single item you buy applies to sales tax. Some are tax-free. There are some states, such as Oregon, that has no sales tax. Okay, which is interesting, but they have other taxes. So we have property taxes. Those of us who own homes, own some property, you pay taxes on that property. We have income taxes, which are taxes that your parents and myself and everyone who's an income earner will pay a percentage of tax to the government to keep our schools going and et cetera, just to keep our world the way we like it. Okay, so those are some of the things we're going to tackle. These are the real world. This is absolutely real world, and I hope you guys do learn something from this lesson, and and maybe be better for it. Let's see. Okay, so this opening exercise, we're just going to look at these, and we're going to ask this question: how are each of the following percent applications different, and how are they the same? We'll go ahead and answer that at the end. I think there are 4 of these to do. But firstly, we're going to solve each problem, and then compare our solution process for each problem. So, okay, so we're going to take a look at these. These are all kind of different applications of using a rate, okay? Interest, for example. Okay, so the first problem here, A, Silvio earns 10% for each car sale. So here's this this example I was telling you about automobile sales persons. So Silvio, he earns 10% for each car sale he makes while working at a used car dealership. Excuse me. If he sells a used car for $2,000, what is his commission? Okay, and we just talked about what commission is. Okay, so commission it equals sale total times a rate. Okay, times a rate, and in this case, what that looks like is we have the sale total is $2,000 he sold this used car for, and we very simply just multiply that 2,000 by 0.10, which of course is equivalent to 10%. Punch that into our calculator. Calculators are very welcome in this lesson, and we get $200. Okay, so Silvio earns $200 for this car sale. Okay, in this case, his this percent was a commission. Okay, it was a commission. So the company gets $2,000 that he works for, and then he's going to get 200 of those dollars. Okay. Okay, $200. Yep. All right. Next, B, a little bit different. Two's family stayed at a hotel for 10 nights on their vacation. Now, the hotel charged a 10% room tax per night, which is very typical. Okay, room tax per night. How much did they pay in room taxes if the room cost $200 per night? Okay, so a couple of steps here to take. Again, at any time, excuse me, it's early in the morning. If at any time you would like to try or attempt these on your own, just to see how you can do without my assistance, please do just pause, okay? But I'm going to just keep going. All right, so here we go. Let's do it. We're going to work this out here. Now, the room tax is equal to the nightly price, okay? So we're looking at $200 per night, of course, times the tax rate, which is 10% room tax per night, okay? So that's really, really important. Okay, I got that per night there. And, of course, we're going to multiply that by the number of nights, okay? And that is 10, okay? So the total room tax is going to equal this this formula we're going to use for that. And we'll just plug some numbers in. $200 is our nightly price. Okay, the tax rate per night, and again, you see those are compatible. Okay, you have a per night tax rate and you have a per night room rate. Okay, so $200 times 0.10, and then of course we're going to multiply that by 10 nights. Okay, and the reason those are so separated there is because the way my screen looked when I was doing this. Okay, so we do that multiplication. Oh, guess what we get? $200 again. Okay, $200 again. Now this tax, it's interesting. If we're interested, we make a comparison now between this room tax and the commission above it. I guess we'll go ahead and do this as we go along. Now this room tax, is $200, is actually an extra charge. I mean, so what happens now is that you have paid. Okay, you're paying $2,000 nightly, for the room. $200 times 10. Okay, that's what you pay to actually rent the room out. Okay, but that tax is on top of that. So the total paid here is going to be $2,200. Okay, how that differs from the commission is the commission. The company, the used car company or dealer, got $2,000. But then they had to go ahead and take $200 of that dollars and give it to Silvio. Okay, so in truth, the used car dealer is ending up with only $1,800. Okay, so a little bit different. Some of them, like a commission, would take away from the total, and tax is going to add to the total. Okay, and we'll watch that happen. Okay, here we go. We have two more scenarios here. We have Eric here. Eric bought a new computer and printer online. Excuse me, he had to pay 10% shipping fees, okay, which is, of course, another real-world item. This item totaled $2,000. How much did the shipping cost? And I think many of you will see how easy this is. Of course, our shipping fees is going to equal the sales total, okay, which is $2,000, times the shipping rate, in this case, is 10%. Okay, shipping rates are not always calculated as a percent, okay, but they are occasionally. So this would be a real situation. Sales total $2,000, shipping rate 10%, and of course we end up with $200 as our shipping fees. And again, this, like the tax, is additive, okay? So not only are you paying $2,000 for the items, but you're actually paying another $200 for the shipping. So now you're paying $2,200, just like in the tax situation, unlike Silvio's car sale, okay? Last one, we'll see how this one plays out. Selena had her wedding rehearsal dinner at a restaurant. The restaurant's policy is that gratuity is included in the bill for large parties, which is very typical, okay? Her father said the food and service were exceptional, so he wanted to leave an extra 10% tip on the total amount of the bill. If the dinner bill totaled $2,000, how much money did her father leave as the extra tip? Looks pretty straightforward. And of course, our gratuity is going to equal our bill total, which is $2,000, times the tip percent. And again, this is arbitrary. It's something that you decide yourself. In this case, Selena's dad, he was so happy that he is going to leave another 10% on top of the gratuity that was already included in the bill. Okay, so in his case, he wants to leave 10%. So bill total, $2,000. Another tip, 10%, and then $200 would be the tip he's going to leave, that extra gratuity. And again, this is similar to Eric's computer and the one before that, in that it is additive. Okay, so that $2,000 dinner bill, you're going to add another $200 to it, and in fact, he also has to pay the other built-in gratuity, which we don't know of. Okay, so here we go. We have some exercises, and again, just like I had told you, calculators are welcome. Okay. In this scenario here, the school board has approved the addition of a new sports team at your school. Yay! Okay, yay. That's usually a good thing. People who want to maybe play flag football or field hockey or whatever. Okay, so we're going to go ahead and look at this scenario, and we're going to look at a few different situations that arise. Okay, that was not right. Okay, I'm going to do that, and I don't know how that happens sometimes. Here we go. Yay. Okay, here we go. All right. So the district ordered 30 team uniforms and received a bill of $2,992.50. Okay. Now that total included a 5% discount. Now this first problem here is takes a little ingenuity here to figure this one out. So hopefully we can get this. You can get this pretty quickly. All right, so the school needs to place another order for 2 more uniforms. All right. Now the company said that discount will not apply because the discount only applies to orders of $1,000 or more, which is often the case. The question here now to answer is how much will the 2 uniforms cost? So, maybe some of you are saying, wow, where do I start? Okay. But since we're trying to find out how much these 2 uniforms will cost, we need to find out, which we don't know yet, the per unit cost of those uniforms. We need to find out a per uniform cost, right? Because that would make sense if that's the question we're trying to answer, okay? But what do we know, okay? And what formula do we know that could help us out? Well, we have our Q equals P times W, which again is quantity, sometimes known as part, equals the percentage times the whole, okay, or sometimes the original cost, okay? So if we plug some numbers in here, well, actually I would love it, maybe you think about it for a little while before I get too hasty and do this for you. Think about what numbers you can actually plug into this right now. And usually that Q, of course, is the total or the amount after something has been applied, okay? Something like a discount or a markup, okay? That's the after right there. Okay, so again, yes, that $2,992.50 is the after. Okay, that is the Q, okay, because it is what we paid after this discount, okay? Now that equals, I'm going to add, there we go, okay, I just explained it right there. Okay, so the reason I'm I'm plugging in that 0.95 or 95% for my percent is because I was given a 5% discount. So if I was given a 5% discount, that means I only paid 95% of that original price, which is that W, okay? And hopefully that's clear, because that is something that really trips kids up, okay? Is that what percentage do I put in here? What numbers do I put where? And that is, boy, if you can lick that, that is quite the achievement, okay? But what am I going to put over there next for the whole? Well, we don't know, okay? That's our W, that's our unknown, that's our variable, okay? So I did that pretty quickly there, all right? Because what we end up with is $2,992.50 equals 0.95 W, and of course we're going to go ahead and divide by 0.95 both sides to isolate our W, and if we do this, you can do this yourself if you'd like. We get W equals $3,150. Okay, so our original price, the original total for all of these uniforms that we purchased, okay, was $3,150. Now, of course, that is not our answer, okay, because that's not what we are seeking to solve for, all right? But it does help us out. So if I were to ask you in the class, how would we figure out a per uniform price? You would tell me, I am sure. All I would need to do. Okay, here we go. What would one shirt cost without discount? Okay, because this $3,150 is the total price without discount, because we've actually taken that away by dividing it by that 0.95. Okay, so what would it be? Well, 3,150 divided by 30, of course. Okay, and if we did that, divide that by 30, we would come up with a per uniform cost of $105. Okay, $105 per uniform. Therefore, we're trying to find out how much 2 uniforms would cost, and that would be $210. Okay, 105 per uniform times 2 more that we need to buy, $210. Okay, and we have no we get no discount on that. Okay, because it was for an order, it was under $1,000. Okay. All right, so let's move on here. Now we have a new scenario. The school district does not have to pay the 8% sales tax on the $2,992.50 purchase, okay, which is very often the case. School districts are often, I don't know if it's always, maybe always exempt from paying taxes, sales taxes, okay, so they did not have to pay it. But what you are going to do, okay, we're going to do an estimate. You're going to estimate the amount of sales tax the district saved on the $2,992.50 purchase. Okay, and then I want you to explain how you arrived at your estimate. So I'm going to pause here, and I would like you to pause and go ahead and work that out. It's an estimate. Of course, you can crunch some numbers, but just an estimate. How much did the school district save on that $2,992.50 purchase? Okay, and remember now, sales tax comes after the total. Okay, after the total. How much did they save? Okay, so let's go ahead and do this. And again, we're talking about an estimate. All right. So, $2,992.50 is approximately $3,000, okay? And this is the way you always start an estimate. You take those numbers, you take those totals you have, and just round them to what makes sense, okay? And usually, in this case, talking about thousands, to the nearest $1,000, okay? So that's about $3,000. Now, my 8% is the sales tax that I would pay. Therefore, all I need to do is multiply by that 8%, which is, of course, 0.08, and I get $240, okay? So a really good estimate of the tax that I saved, the district saved, would be $240, okay? About approximately $240. Actually, a little bit less just because, $2,992.50 happens to be $7.50 less than $3,000, okay? But that's not a big deal. We're only trying to estimate, which is wonderful. That's a great bit of savings there. Okay, further on into our example here with this new sports team. So a student who loses a uniform must pay a fee equal to 75% of the school's cost of the uniform, okay? So that's quite a hefty fee, but the truth is, the school is actually eating another 25% of that cost. So a student, really, if you lose something like that, you should pay the whole cost, but you get a little bit of a break here. You only have to pay 75% of the cost of the uniform. So, for a uniform that cost the school $105, okay, will the student owe more or less than $75 for the lost uniform? Okay, and explain how to use mental math to determine the answer. Okay, so these are what I'm going to write down here in a minute, is kind of what's going to be going on in my head, okay, mentally, all right? But go ahead and think about that. How would you use mental math to determine the answer to this question? The question is, will the student owe more or less than $75? We don't really need a figure, but just need a more or less. Okay, so I'm going to pause here and have you just muddle over that and come on back. Okay, so if we're going to go ahead and muddle over this, I know that this 75%, of course, means $75 per every $100, okay? So just knowing this 75% means 75 per 100, I'm thinking that in my head. Okay, 75 per 100, 75 hundredths, okay, in this case the price. So what I'm thinking is that, okay, a $100 uniform is going to mean that I'm going to pay $75 right there for a $100 uniform, okay? $105. Now, this $105 is more than $100, okay? Therefore, I can say inside my head, therefore, 75% of $105 would be more than 75%, or $75, okay? And that is, it's not a heck of a lot more, that's for sure, okay? But it still would be more than $75, simply because 75% means 75 out of 100, and so that means a $100 uniform would cost me 75 cents in fees, $75 in fees. Therefore, anything that's higher than that, cost more than that, is going to cost me more than $75 in fees. Okay? So yeah, just to see what you can do with these numbers, trying to get used to, trying to get more comfortable with throwing these numbers around in your head. All right. Okay, so for part D here, what they want you to do is to go ahead and write an equation, okay, to represent the proportional relationship between the school's cost of a uniform and the amount a student must pay for a lost uniform. Okay, now we're going to use a couple of different symbols here. We're going to use, or variables. We're going to use U to represent the uniform cost, and S to represent the amount a student must pay for a lost uniform. Okay, another question, again, after we come up with this equation, we are going to answer, or look again at this constant of proportionality, and we're going to determine what that constant of proportionality is. Okay, so how do we throw this together? Well, we have U and we have S, okay? So we're going to find this relationship between the uniform's cost and the fee that you must pay if you lose it, okay? So we want to know what that fee, how that fee compares to the cost. So we would have S, which is the fee the student must pay, equals, okay? So 0.75, which is 75%, 0.75 U, okay? So whatever that uniform cost, you are going to pay 75% of that uniform's cost as your fee, and that is it. That is our equation right there, and we can apply that equation in any situation, because it's not just for a $105 uniform. I mean, if the whole uniform kit cost $200, okay, you would still apply this 75% of cost fee for anything that's lost, okay? So there it is. Now we can apply that to whatever. Now our constant of proportionality, therefore, okay, is going to equal 75% or 0.75. And what that means, we take for any increase in the number of uniforms, it's going to increase, our fee is going to increase as well, okay? So we can plug any number in there for uniforms, and our fee is going to go up by that same percentage, okay? The same percentage. This is the unit rate, okay? The unit rate, 75% of whatever number of U we have. Okay. A taxpayer claims the new sports team caused his school taxes to raise by 2%, which again is a reality. Okay, very often, schools rely on the neighborhoods or the population of that community to pay an extra tax to build new facilities or et cetera, et cetera. Okay, so again, another real life situation. Okay, now what we're going to do here is we're going to write an equation, okay? Write an equation to show the relationship between the school taxes before and after the 2% increase, okay? Use B, in this case, to represent the dollar amount of school tax before and the increase, and T to represent the dollar amount after the 2% increase, okay? Again, we're writing a relationship equation. This equation is going to show this relationship, which then can be translated into what we call a constant of proportionality, okay? So if we go ahead and do that, we have T, okay? Now T is the after the 2% increase, which should always be the case. That number or that variable on the left side of the equation, just like the Q equals P times W, that Q is always the after the effect of the tax, the rate, the whatever. Okay, this is the same way, because that T is the after the increase, okay? That T is going to equal, of course, 102%. And again, hopefully this isn't still tricking you, and you guys can work this out on your own, because a 2% increase, okay, of anything means that you're going to have to add that 100% to it, because you've got the original fee. The original of anything is always going to be 100%, okay, and then you need to add on, in this case, 2%, so 102%, okay, which looks like this as a decimal, 1.02, all right, times B, which was the before, okay? So we had this before tax rate. We add another 2% to it, which is going to make it 1.02B. And that's it. That is our equation in a nutshell right there, okay? Knowing what to do with these various numbers in a word problem so important. And as you can see, we are nearly at 30 minutes. We are not halfway through. This is going to be a long lesson. So let me continue here. All right, so now we're going to go ahead and use the equation to complete the table below, listing at least 5 pairs of values. And what we're going to do eventually with these pairs is we are going to plot them on a number line. So I'll start you off here, and then I'll have you complete this table, and then come back and take a look at the answers. Okay? So here we go. Let's look at that 1,000. So all this is a matter of plugging in these values into our equation above. So if I have $1,000 for my B, I plug it in there. T equals 1.02 times 1,000, which equals 1,020. Okay, so T in this case equals 1,020. All right? And go ahead. I'm going to pause right here, and why don't you go ahead and complete this table. Come on back. I'll just give you a hint for the first one. This one right here, let's just use 0, 0. Okay? Okay, so we're back here. I'm just going to go plug these in. For 2,000, it's just going to be 2,040, because 2,000 is double 1,000, and 2,040 is double 1,020. All right, for 3,060, a little bit different, because now I have my T value already. I need my B value, so I'll just go ahead and do this one for you. Plug it in. 3,060 equals 1.02B. And do the division. You know how to do this. Isolating for that B. My B is going to be 3,000. Plug that in. What do I notice about that 6,120? Well, just so happens to be twice 3,060. Therefore, I know that my B, or my before taxes, was $6,000. Okay? And then again, like I had said, let's just use 0, 0, because if you had 0%, 0 tax beforehand, you would have 0 tax after, because anything multiplied by 0 is 0. All right? So, if we go ahead and do this, I'm just going to go ahead and fill this whole thing in so everybody can see it. There we go. There's my chart again, or my table. And now we're going to go ahead and graph. Now, what I'd like for you to do is, if you would, go ahead and get some graph paper, create your own graph, okay? Be sure to label the axes and the scale, okay? So go ahead and do that. I'm going to pause. You go ahead and do that, and come on back. Okay, welcome back. Let's see what you got. I'm going to show you how I just put together my thing here, my graph. Okay, labeling both axes. Okay, I'm independent as my X, my dependent as my Y. I have a title for my graph, so all my labeling is done right now. Okay, I'm going to go ahead and just mark in. I'm going to do 1,000 per box here. Now, what I did right there, I just wanted to show you this real quickly. I went ahead and changed this to, when you put in parentheses, you just tell you what unit you're using. So here I have tax after increase was in dollars. That's straight dollars. So that means that is $1,000 right there, okay? But at the bottom, if I'm going to label my axes down here, my points, and I don't have enough room to write 1,000, 2,000, 3,000, 4,000, I can just show that here, and I can write tax before increase in thousands of dollars. Okay, so if I put that in parentheses, that means if I look at 1, that means that's $1,000. I'm not sure if you've seen that. You probably have seen that before on a graph that you've seen in some publication. But I just wanted to make you aware of that, and you can go ahead and use that yourself, because it's this is quite an art, actually, the design of a nice, usable graph. Okay, we'll continue labeling. All right, and then I go ahead and I plot my points, draw my line. It looks something like this. This is not perfect because these boxes are so small. I felt a bit crammed in here, so I'm not exactly happy, but the line is moving straight, and it also has a couple of things that would help us decide whether it is indeed a proportional relationship. Does this graph show a proportional relationship? That is a question. We've asked this question of ourselves very often, okay? And what do you see? Well, you see, yes, it passes through that very special 0, 0 point, okay? And it is a straight line. It doesn't do any curving or anything, okay? It's a straight line. So, yes, it is. Shows a proportional relationship, okay? Constant of proportionality, and what might that be, okay? And of course, that constant of proportionality is the place where your independent variable is 1, okay? And that independent variable is right here, okay? And that's that tax before increase, that 1,000, okay, right there. And when it's 1,000, the dependent variable, a tax after increase, is 1,020. What's the relationship between those two numbers? And that is 1.02, okay? So for every point on the x-axis, okay, all I do is multiply it by 1.02 to get the corresponding point on the y-axis, okay? Alrighty, and hopefully that was clear. Just go back there one more time, okay? The constant proportionality being 1.02, which is pretty obvious because if you remember over, hold on a second, let me just go back over here. Right here would show us our constant of proportionality as well, all right? Okay, moving along. Okay, we did that. And we did those. Okay. So what is the... Okay, now we know the constant of proportionality. We got that, 1.02. But what does it mean in the context of this situation? And what it means, well, I guess I just explained this as well. But it means that after the tax increase, $1.02 will be paid for every dollar that was paid before the increase. Okay? So if you paid $1 tax before the increase, you will now be paying $1.02 tax. Okay, so that would look like, if we're going to make it a point on the graph, it would be 1.02. Okay, and we remember that from Module 1. Okay. All right, so F. Here we go. If a taxpayer's school taxes rose from 4,000 to 4,020, was there a 2% increase? Okay. You can justify your answer using your graph, table, or equation. I am going to choose to use a very handy equation, okay, because I don't like the way my graph turned out. I don't think my points are really represented really well, so I think if I default to this equation, excuse me, I will be very safe, all right? So go ahead and do that. I'm going to pause. Go ahead and work that out, see what you get, and then come on back. Okay, and using a formula, of course, I'm just going to plug in some numbers. Okay, if correct, 4,020 will be equal to 4,000, okay, times 1.02, all right? If this is correct, because this is going to be my after the increase total, before increase total, and then my constant of proportionality, or the amount that it's going to go up, okay, this percent increase, okay? If this is correct, this equation is going to be true. Let's go ahead and look if it's true, and you know how to do that, okay? We're going to go ahead and, of course, find out that no, it is not true, because all I needed to do was to go ahead and do my multiplication here, and if I multiplied 4,000 by 1.02, I get 4,080, and that is not equal to 4,020. So I know it is not correct, okay? All right, here we go on to 3. Whew, still continuing this problem. It's a long problem, huh? The Sports Booster Club sold candles as a fundraiser to support the new team, okay? The club earns a commission on candle sales, okay, which means it receives a certain percentage of the total dollar amount sold. If the club gets to keep 30% of the money from the candle sales, what would the club's total sales have to be in order to make at least $500? Now, hopefully, for all of you, some of you, most of you, this problem looks somewhat familiar. Okay, all we need to do, again, I'm circling and underline all the pertinent information. Okay, we need to find out the total sales that they would need to have. Okay. All right, in order to make at least $500, okay? And again, it's about plugging numbers in to the correct place. Always start off just right, help yourself out immensely by just writing down that formula, whichever formula applies. They all pretty much mean the same thing. They just use different letters for, different aspects of this whole very similar operation. So I'm going to use the Q equals P times W. Again, Q being that after the fact, the new amount equaling the percentage times the original amount. Okay, so if I go ahead and do that, this $500 is what I want to make. Okay, I want to at least make $500. So that's going to be my after applying how much we make on sales, okay? And that's going to equal, of course, 0.3, because I'm going to go ahead and we're going to earn, the Sports Booster Club is going to earn 30% of all of those sales, okay? So you see what's happening here. I am just plugging in, I am doing nothing except taking this formula and just plugging in what I know, and then, of course, what I don't know, which is the club's total sales. I don't know that, but I'm trying to actually aim. I'm trying to find something I can aim for in this case. I need to aim for a certain amount of sales so I can make my $500, okay? And if I continue that out, 500 equals 0.30 W, okay? And do my division, again, to isolate that W, and I find out that W, or the total sales I need to make, the whole sales, needs to be, in this case, at least $1,666.67. Okay? Needs to be at least. And you might remember how we might have said that before. Okay? W needs to be greater than or equal to $1,666.67, okay, in order that we can, or the Sports Booster Club can make or earn $500 profit, okay, $500. Alrighty, moving on. Any questions? Hey, I'm always available. All right, and the last thing here is, yes, candle sales will need to total at least $1,667.67. Okay. All right, here we go, number 4, and we have Christian's mom here. Christian's mom works at a concession stand, or the concession stand, during sports events, okay? She told him they buy candy bars for 75 cents each and mark them up. Ooh, here we go, mark them up. Mark them up 40% to sell at the concession stand, okay? What is the amount of the markup? Okay, we don't know the amount of the markup, and the amount now is the cents or the dollars or whatever, in this case cents, markup. All right, and how much does the concession stand charge for each candy bar? Okay, so there's a couple of questions here. We're going to solve for one of those and then apply that solution to find the answer to the next. Okay, let's go ahead and plug it in. All right, 2 questions. All right, 2 questions, 1 formula, okay? Q equals P times W. Again, knowing what to put where. I'd like you to look at this and come up with some idea of where you want to put which values, and then come on back and see what I do. Okay, so let's plug some numbers in here. Our Q. What is our Q? Do we know our Q? Well, we don't know our Q, but what we do know is we do know our percentage, in this case, the P. All right, they're going to mark them up. And again, oh boy, I really hope that this is just becoming second nature to you. If I'm going to mark up by 40%, I need to use the percentage 140% or 1.4 to show that, okay? And of course, 75 cents is the cost of the candy bars to the concession stand that Christian's mom told him about, okay? Again, do my multiplication, okay? Q equals $1.05. So now what we've found out here is we found out the actual charge for each candy bar, okay? So this is what our candy bar is going to cost after, excuse me, the markup, okay? Which is always Q is always that amount that is after applying a markup or a markdown or a discount or whatever, okay? And now what we need to do, though, is we need to find out the amount of the markup, okay? What was the amount? Now we know the percentage markup was 40%, but what was the amount? How much profit did we make, or are they making on each candy bar? And that's very easy. We take our sell price, which is $1.05, which we already solved for, and we subtract away our cost, which is 75 cents, and therefore, I said 35, that's actually 30, huh? Okay, yeah, 30 cents. So 30 cents is our markup amount, okay? 30 cents. They're making 30 cents on each candy bar sold. Different than percentage, okay? Yeah, the percentage markup was 40%, but the actual dollar and cent markup was 30 cents. Okay. All right, here we go. So over here it says with your group, okay, which we know is not going to happen, okay? With someone, maybe your mom, dad, sister, brother, friend, okay? Brainstorm solutions to the problems below, okay? I'm not going to prepare a poster. That's the next part of that. That would be fun to do in class, but can't do it when you're there alone at home, okay? And a calculator, of course, may be used for all calculations, all right? So here we go. Now we have a new scenario here for the next school year. The new soccer team will need to come up with $600, okay? That means the soccer team, its boosters, everyone that supports it is going to need to earn or fundraise for $600, okay? So, start off with here, we're going to suppose the team earns $500 from the fundraiser at the start of the current school year. So they got this $500, and the money is placed for 1 calendar year in a savings account earning 0.5% simple interest annually, and that is pittance. Boy, that is really pitiful. How much money will the team still need to raise to meet next year's expense? Okay, so that question is very important because it's not asking you how much money would they earn in this account, okay, which is you're going to find out is going to be really, really minuscule. But the question asks how much will they still need to raise after this savings account interest earned. All right. Again, here we go. We're plugging in. Okay. Here's our target. Remember, target is $600. Okay. And now we have our I equals PRT. Okay. So we're talking about savings and we're talking about interest rates. Okay. So our interest is going to equal 500, which is our principal. Remember, all of these what all of these letters stand for, okay, principal, and that's going to be multiplied by that. Now look at that number. Boy, is that a real pitiful looking number. 0.005, because that is a half of a percent, okay? easy to look at this thing as maybe being 5% when you look at it up there, but it is actually just 0.5%, which is next to nothing, okay? All right, yikes is right. Oof. Okay, and then times 1, because we're only placing it in there for 1 calendar year. This is an absolute waste of money as far as I'm concerned in real life. And that's going to equal $2.50. Can you imagine? Put it away, put $500 away for 1 year and earn only $2.50. Woo, something you don't want to do, okay? So there we go, 2 cents. We haven't answered the question, of course, because the question was how much will the team still need to raise? And of course, that's going to be $502.50 is how much they've raised at this point because they have that $500. But we're going to subtract that away from $600, which is the target, and we still have $97.50 left to collect. Okay, $97.50. All right. And now, Jeff is a new member of the new sports team. His dad owns a bakery, like my dad did. To help raise money for the team, Jeff's dad agrees to provide the team with cookies to sell at the concession stand for next year's opening game. Okay, the team must pay back the bakery 25 cents for each cookie it sells. Okay, so it's got to pay that back. The concession stand usually sells about 60 to 80 baked goods per game. Okay. Using your answer from part A, of course, that's the $97.50 we're left to collect, okay? Determine what percent markup for the cookies the team plans to sell at next year's opening game, okay? Justify your answer. Okay, so you're going to determine what markup you're going to need to apply to each cookie sale, okay, to actually earn $97.50, okay, because that is our goal, okay? This sounds really convoluted. You're looking at all this. You've heard me read it. You're reading it yourself, and you're probably saying, wow, where do I start? Well, you know where to start, okay? Oh, and again, this is 1 day only because it's 1 game, okay? You start by first estimating how many cookies we will sell, okay? So they're telling you here you're going to sell between 60 to 80. If you're doing something like this in real life, you find yourself in this situation, very, very safe, very, very safe to estimate at the low end, okay? You want to plan for the worst case scenario, okay? Worst case scenario, and we're going to call that 60, of course, because they're selling between 60 and 80 baked goods per game, okay? We got it. Worst case scenario is 60, all right? Now we need to earn $97.50 from 60 cookies, okay? This is what we need to earn, $97.50 from 60 cookies. We're going to just estimate that. We know we need to earn $97.50 still, but we're going to estimate we're going to sell 60 cookies, okay? So this is about $1.63 per cookie. How did I get that? Of course, I got that by dividing $97.50 by 60, okay? So I'm going to need to sell each cookie for $1.63 to get $97.50 from 60 cookies. But I'm going to ask you, and I would ask you in the classroom, I would say, well, there's something else I need to consider. And what was that? What else do I need to consider here? Well, I need to remember that we must pay back 25 cents per cookie to Jeff's dad, okay, to the bakery shop, all right? So if we go ahead and add another 25 cents to cover the bakery fee, and then we're going to come up to what, $1.88, okay, $1.88. And again, this is real world. I mean, some of you may have different answers to different things because we're just kind of estimating and guesstimating. But I'll tell you honestly, if you're going to sell something at a concession stand, at a sports game, you don't want to mess with any cents whatsoever. If you can you can avoid it. Okay, everything should be straight dollars, right? So therefore, we're going to go ahead and say, how about $2 a cookie? Okay, $2 a cookie. It's reasonable. People will pay it, especially when they know the money, the profit is going towards a kid's sports team. Nice and easy. And it also guarantees, because 188 is going to get us our 97.50. If we sell them for $2, we're going to get at least 97.50. Okay. All right. Now we need to determine a percent markup. Okay. So we've gotten to this point. All right, where we have I'm going to sell for $2. All right. So let's go ahead and plug some numbers in. Now, markup rate calculation. How do we decide what our markup rate is going to be? Well, we can use our Q equals P times W. Again, our Q being our after, and of course that is going to be our markup is $1.75, okay? And our $1.75 1.75 is going to equal the percentage times 0.25, okay, 0.25, because that is what we need to give to the bakery shop, okay? That's our cost per cookie right there, and then our markup amount per cookie, okay? We have $1.75 is what we're marking up, because we're starting here from 25 cents is our cost, and then $1.75 is what we are marking up, because those two, if you add $1.75 plus 25 cents, of course that's going to be our $2 right there. Okay, all right. And now we're trying to find out what percent we multiplied by 25 cents to get to $1.75. Okay, AKA that's our original cost. Yeah. All right, and again, to solve for P, we're going to divide by 0.25 on both sides, and then P equals 7. So that means our percentage equals 7, and hopefully many of you know, or most of you know, or all of you know, that this 7 in percentage terms is going to equal 700%. So we have marked up these cookies 700%. Woo! Sounds like a lot. It is a lot, but still we were able to, because Dad, he gave us such a great price, 25 cents per cookie, and then multiplying that by 700% gave us our price of our markup of $1.75, and therefore we can sell them at $2 each, which is still reasonable to the public. All right, here we go. So now we're going to go ahead and plug some numbers in. Now we have an actual here. Okay, suppose the team ends up selling 78 cookies at next year's opening game. All right, what did we plan for? Remember, we planned for 60. Okay, we planned for 60. All right. Now we're going to find the percent error. Okay, we're throwing this at you again. We've had this before. In the number of cookies that you estimated would be sold in your solution to part B, okay? And just to remind you here, the percent error calculation is right here, is absolute value of the actual minus the approximate, or actual or exact value minus the approximate value, divided by the absolute value of the exact value, or the exact amount, okay? Plugging in those numbers, all right, our percent error here is going to equal absolute value of 60 minus 78. And again, these are absolute value signs, okay? 60 minus 78, because 60 was our approximate value. That was what we had estimated we would sell, and minus the 78, which is what we're saying in this scenario is what the team actually sold, all divided by the absolute value of 78, which is the absolute value of, excuse me, what was actually sold. All right? And that, of course, translates into 18 divided by 78. Okay, again, absolute value, never a negative number, which equals 0.2307. Okay, and our percent error there would be 23%, because that's what this turns into, around 23%. So our percent error in this case was 23%. It was a good error though, because we estimated low. We estimated we would sell 60, and we actually sold 78. And those are really good surprises. Good surprises. Okay, here we are at lesson summary, and just over an hour. So sorry. I tried hard, but there was a lot of information, a lot of things to do in this lesson. Okay? Lesson summary. There are many real-world problems that involve percents. Okay, I'm not sure what happened there. My timer stopped. Looked like I paused. The thing paused. But anyway, lesson summary, there it is. You can read it for yourself. I really didn't say anything profound. I was just about to say that this is the end. This is the last lesson in topic B. So you're going to go ahead now and do your mid-module assessment. If you can do that this weekend before the coming Monday, you could take that. You could take a new assessment in class, new mid-module in class this coming Monday. If not, don't worry about it. We can just do it on the coming Monday. Okay? All right, you guys and gals, good luck. Any questions, give me a call.